Hi, this is Chris, and we are taking a look at a question dealing with triangles. So here we're probably going to have to use some sort of trig functions to solve for either a missing side or a missing angle. So let's take a look. It says the welder is making a triangular wire frame with side lengths of 7 feet, 9 feet, and 12 feet. What is the angle between the shortest two sides? Okay. So first, let's try to draw out a triangle, and they don't give any identifiers here as far as how to draw this triangle. They don't tell us that the shortest side is horizontal or on bottom or anything like that. So we can just draw a triangle. It doesn't have to be perfect, and we can start labeling some sides. So we'll go 7, 9, 12. And again, we don't know any of the angles. We don't know which side is which, but as long as you label them, then you'll find your corresponding angles relative, to those. So they want to know the angle between the two shortest sides. So our shortest sides are a side of 7 and a side of 9. So the angle between those is this angle here. This is the angle that they're asking for. And so to solve for a missing angle, we have a couple laws that we can use. We can use a law of sines or a law of cosines. And it's important to recognize here, this is a great application of law of cosines because we're not given any of the angles. To solve for law of sines, you would need at least one angle. But in this case, if you don't have any angles, then you're going to have to use law of cosines. So that's our main thing to recognize here whenever you're deciding between law of sines and law of cosines. If there are no angles given, it's always law of cosines. And our law of cosines, let's see if we can figure out what that is. And that would be c squared equals a squared plus b squared. And then it's going to be minus, this will be 2ab cosine c. And when we use a capital letter, so that represents your angle, and then the lowercase version of it represents your side length. So here, it doesn't really matter which one you would call A and B for this particular triangle, but we're going to call this corner here, this vertex C, so that would be the angle we're solving for, and then this would be little c. And the convention for triangles, and this is important just for us to get in a habit of making sure that we actually draw them out the same way every time so that it's easy to label stuff and know what we're solving for. You're going to have your corresponding side across from its corresponding angle, which means that here for angle A, for capital A, big A, will be across from little a, which is your side length. Here, angle B, capital B, will be across from lowercase b, which is our side length there. And when we have law of cosines and we have everything labeled appropriately, now it just becomes a little bit of a plug and chug. It's still not that easy for us to do that. We have to make sure we're really careful about the math involved, but nonetheless, we have everything that we need here, and now it's just a matter of plugging in and solving accordingly. So here for little c, we have 12, so this will be 12 squared. We have everything we need from the question, so we're going to move that up for now. And this is equal to 9 squared plus 7 squared minus 2 times 9 times 7 cosine of angle C. And again, that's what we're solving for, so that's going to be our variable. And we're just going to walk through this stepwise here. You can probably type it all into your calculator in one fell swoop if you're comfortable, and if so, that's great, but I want to write out each step here just to make sure that we have everything easy to track. So we're going to have 2 times 9, 6, 18 times 7 would be 126. Yep, that's correct. Okay, and then cosine C, 81 and 49, it's 90 and 40 is 130, so we have 144 equals 130 minus 126 cosine C. Subtract 130 from both sides, so we would get 14 equals negative 126 cosine C. And when we go to solve, we're going to have to divide by negative 126. So negative 0.1 repeating would be cosine C. And to solve, you're going to take the inverse trig function there, your inverse cosine of negative 0.11 would be 96.379 and change, so we'll call it 96.4 degrees for angle C. Now it's always helpful when you're done with any of these law of sines, law of cosines questions to just take a look at that angle and look at it on your triangle and see if it makes sense. Well, little c, this was our longest side. And so in theory, your longest side of your triangle should be across from the largest angle. And it makes sense because 96.4 would have to be the largest angle. If that one is obtuse, angle A and angle B would have to be acute. So that checks out, and it works out that this answer makes logical sense. And from our calculations here, that's how we can see it making mathematical sense. Up next, we're going to take a look at a few more questions where we apply law of sines and law of cosines.